Yes, ma'am. You're online. Andrea,
Hey.
you're on. You're on.
Oh, nice. Okay. So my name is Andrea. I'm from Italy, and I'm in Italy actually. I work in Sweden right now with a company called Football Addicts, and I do Elixir full time there basically. And I'm pretty active in the Elixir community, and I contributed to a bit to everything in the Elixir Lang scope of things. So Elixir, Acto, and Plug, and I wrote get text with Jose, which is an internationalization localization library for Elixir, and yeah, that's it. So today I wanted to talk about Radix, which is a Redis client for Elixir that I wrote from scratch. So not a wrapper around an Erlang client. It's a native Elixir client, and I think it shows quite a lot of the features of Elixir, and yeah, it showcases a lot of the things, patterns you follow when doing Elixir, and the things you can do with Elixir. So I have very ugly slides to show this. So I'm gonna share the screen. This is good. Okay. Can you see the screen? I hope. Yeah.
Can you increase the size? Yeah.
Yeah. Let me just find out how to do this. Okay. So I'm not gonna use the presentation mode because it's hard. So basically, okay. So we want to write basically a client for a driver for the Redis key value store in Elixir. So what we want to do on a very high level is have a Redis server running and Elixir talking to the Redis server. That's just it. And so Redis is a TCP server. So the first thing you want to do is obviously connect to the TCP server, and Redis basically uses its own protocol to encode and decode that data that you send from and to Redis. It's called RESP, I think, which is Redis something protocol, and that is on top of TCP. So basically, you just exchange binary data through TCP, and you encode it according to the protocol, both, and decode it when it's back. And yeah, so there's one particular module that we want to use for doing this in Elixir, which is called GenTCP. And it's a very simple tool that provides means to create a socket and send data through the socket and get data back from the socket, TCP socket. So basically, you do something like gentcp.connect, and you connect to, I don't know, localhost. So you connect to a NOS and a port, and that's where you connect to Redis, which is, I don't know, running on a machine, and then you get back. Let's do this. You get back a tuple with the socket in it, right? So right now you have the TCP socket, and you can really easily send data to the socket. So you can send just binary data, of course, to the socket, and it works. I mean, a socket works pretty much like a process. If you're familiar with an Elixir process, I mean, if you're familiar with that, so you can send messages to a process, and in the same way you can send data to a TCP socket, and you can get back data from the sockets in the same way you receive a message from an Elixir process, right? So when you send a message to an Elixir process, the sending of the message is asynchronous, meaning that you don't know if the process is when and if the process is gonna receive the message, the process you're sending the message to, of course. And so you just send the message and go on with your life. And this is the same thing with GenTCP. .send, which is basically you just send binary data over the socket and keep going without blocking and waiting for a response. And then you have a bunch of ways to get data back from the socket when the server responds in case of Redis. And the simplest way, there's a function called gentcp.receive, which basically is like the receive built-in function in Erlang and Elixir, because basically it's blocking, meaning that you block until you get here. I'm passing the amount here, which is the number of bytes that you're gonna want from the socket. So it's not gonna send you anything until it has that number of bytes, and it's not gonna send you more than the number of bytes. But basically, you block until you have data from the TCP socket to get back to your process. So using send and receive is very, very similar to what you do when you exchange messages between Elixir processes, right? So you send, and sending it's asynchronous, it's non-blocking, and then you receive, and receiving is synchronous, and it's blocking until you get a message. And in Elixir, you have the after keyword in when you receive a message, which specifies a timeout. Basically, it says if you don't get a message in this timeout, so in 1 second or 2 seconds, just fail and go on, right? So you don't block indefinitely, which could cause problems. And this is actually pretty much the same with receive, because you can pass timeout to GenTCP receive as well. So it's very, very, very similar to what happens when exchanging messages between processes. So I forgot to mention that if you have any questions, I have your I can see all of you, so just raise your hand and I'll stop. Okay, so this is really the basics of TCP. It should be. I hope it's clear, because it's pretty simple. But if you have questions, just raise your hand. So now that we have a basic understanding of how TCP works in Erlang and Elixir. So the thing you can do, of course, is every time you want to send a command to Redis. So what you can do is open basically what I have on the screen. You just open a new socket. You send the data encoded according to the Redis protocol, which we're not covering here, but it's pretty simple. But you will send this data through the socket. Then you will receive the response of the server, and you will close the socket, basically, right? There's gen tcp.close, and you will close the socket. And this is really the simplest thing that you can do to exchange data. But I mean, it has like a billion problems, because the first one is obviously you don't want to open a new socket whenever you want to send a command to Redis. This is very very hard to scale, right? Because if you have, say you're building a web application, and like in Phoenix, where every client request to the web server is a different Elixir process, right? So in that case, say every request hits Redis at some point, so you would have maybe thousands of Elixir processes connecting to Redis, right? So thousands of sockets open just to talk to Redis and then close right away, right? And opening the socket tends to be a somewhat expensive operation, because you have it goes through the operating system. It has to reserve resources. It has to I don't know, open file descriptors. It has to do all this bunch of stuff, which is pretty expensive. So you don't want to do it continuously. You don't want to continuously open and close sockets just to send a command, right? So this is the first things that pops to mind, is we can't just open a socket whenever we want to send a message and receive the response and then just close the socket right away. So the first solution that comes to mind is, like, we have to keep these sockets open and we have to reuse it for different commands, right? So there's the idea is we want to keep these sockets in a state. So we want to keep these sockets in a state and like read it from the state every time you want to talk to it, right? Every time we want to send data on the sockets. And when you hear state in Elixir, it usually means there's going to be a gen server somewhere, and this is a case where a gen server works well. So I'm not sure. Can you raise your hand if you know what a gen server is? Okay, so this is less than I expected, but so let's go very quickly through what a gen server is. And basically, a gen server is an Elixir process, and as the naming says, it's a generic server, right? So it's a process that acts, let's say, as a generic server, as a server. Like a web server, you can think of it like a web server. So it has basically, it holds some state, right? So and what you do is you, from other Elixir processes, you can communicate with the gen server so that you can read the state and update the state, and the gen server basically keeps running and keeps this state internally, right? And all communication from other Elixir processes to the gen server is, of course, through messages, which is the only way to communicate between Elixir processes. And so it's a very easy abstraction to build if you wanted to build it by yourself, but it's provided because it's a very common pattern. So basically, you have you do kind of a small scale like web server. So you have this process that responds to requests, right? So you do a request on the gen server, and the gen server replies with a response back. And yeah, so that this is really all we need to know about a gen server. And so it's a very common abstraction when you want to hold state in Erlang, because, as you know, Erlang and Elixir are basically immutable languages. The data structures they use are immutable. So if you want to end their Erlang is nothing shared language, so processes can really ever share state, right? There's no such thing as a shared memory space, and there's no such thing as I don't know, and there's no way to share memory between Erlang processes. So the gen server is an abstraction often used just for that, because you basically hold the state in a single process, because a process has its own memory, right? So you can hold the state inside the process, and this process acts like a kind of shared memory, right? So every other process can read the state of this process by just asking for the state of this process by sending a message to this process, right? So say you have a gen server with a state in it. So if you want to know the state, you just send a message to the gen server that says, hey, what's your state? And the gen server is gonna reply with, hey, this is my state, with another message, right? So this is the only way to exchange data, right? Because when you send a message to a process, the data that you're sending is actually copied over to the process that you're sending a message to. So basically, there's still no shared memory anywhere, but like it is a good abstraction over shared memory because it looks like shared memory because all processes can access and this shared memory, and of course all processes can modify this like shared the gen server state if the gen server allows it, right? So you could send a message to the gen server saying, hey, update your state with this function I'm passing you, right? And the gen server can simply say no, right? So or I don't know, it can say sorry I'm busy, or sorry another client has to update the state before you, and I still haven't updated the state. So so it can handle like modifications to the state internally. But I mean, it's a good abstraction over. You can use it exactly like shared memory. This is what I mean. You can use it like everyone can see this memory if the gen server allows it, and everyone can update this memory if the gen server allows it. And yeah, let's say that this is all we need to know about gen server for now. And so what we can do to take advantage of gen servers in the situation I talked about here with TCP stuff is basically what we can do is we basically keep the socket, the TCP socket, inside the state of the gen server, right? So this way, as I said, it's very easy to share memory when a gen server is between processes, to share stuff between processes when a gen server is around. So what we can do is we keep the state, we keep the socket in the state of the gen server, and we can read that socket from other processes just by asking the gen server to hand the socket over to the requesting process. And this way, it's very, very straightforward because we have just one. We only open one socket in the whole system, and every other Elixir process can just read this socket and send data through this socket. Basically, everyone can do this without having to open a new socket, right? You just open one socket at the beginning, like when your application starts, and you keep it in your gen server state. So this is very, very, very simple architecture. So one thing you can't do though, it's since what I said, receiving is harder than sending. So let's start with this, because so when you send a message, you know what the message will be. You can encode the message according to the Redis protocol. You can just send it over to the through the socket, and it just ends up in Redis. So what happens if multiple processes read the socket from the gen server at the same time and send messages to the Redis server? So this works fine, right? Because every time a process asks the gen server for the socket, the gen server is gonna send the socket. It's not gonna, of course, it's not gonna like send in the sense that it goes away from the gen server and ends up in the requesting process. It just copies the socket over to the requesting process. So basically, if a process asks the gen server for the TCP socket, both the gen server and the process are gonna have the TCP socket available, right? So each process this way can send data through the socket. But the problem, so sending is easy because, I mean, we have control over sending, right? But we have much less control over receiving data because we're not gonna know when the server is gonna reply, right? And we're not even gonna know how much of the response the server is gonna reply, because if the response is very big, it's gonna be split up in several TCP packets. So we're not gonna probably not gonna get just one single packet. So we're not gonna know like is this a complete response? Is this a part of the response? So it's receiving. It's much harder, and it requires much more logic and much more control to handle. So basically, what I mean is you can't just take a TCP socket. You can just request a TCP socket from a process, send data, and then block that process over the TCP socket, waiting for new data with gen_tcp.receive, right? The one I mentioned earlier. So you can do this pattern. So gen_tcp.send. You can send basically data over the socket, and then just call gen_tcp.receive and block for the response. So you would get like okay, some data and block like that. You can do this if you're the only process messing with the socket, right? Because if two processes send data through the socket at the same time and both block on that socket, the socket is gonna send the data to the first process that blocked, right? But you don't know, you're not sure that the first process that blocked is the first process the server is gonna reply to, right? Because you're not sure the messages are gonna end up in the server in the correct order, right? So what we do is, since we have the gen server and the gen server holds the socket, what we can do is, instead of asking the gen server for the socket and sending data ourselves, I mean the process that asks the socket, what we can do is we can ask the gen server to send data through the socket for us, right? So one thing I maybe this will make it clearer a little bit, but a gen server. So when you do a request to a gen server and the gen server handles this request, it will handle the request synchronously, meaning it will only handle that request in that time. The gen server is a single process, right? And in Erlang and Elixir, a single process can only do sequential work, right? You can't do any parallel work without spawning other processes, right? So when you handle a request in a gen server, you're handling that request sequentially, right? So you can do anything that you can handle other requests while you're handling a gen server request in a gen server. So it's kind of, so gen server works as kind of serialization mechanism. So even if thousands of processes asks the gen server to do stuff, the gen server is still gonna process, is still gonna do stuff one request at a time. It's gonna handle one request at a time. So, and this is one reason, because gen servers often can end up being the bottleneck of Elixir applications, because because of what I just said. So say many processes send requests to a single gen server. The single gen server is gonna still process these requests one at a time. So it doesn't scale, right? So because the more processes you add to that request stuff to the gen server, the more like time it will take before your request gets handled. But this is actually what we want in our case, because we want to send and receive data basically like we want to serialize this, right? So we don't want to send data like many processes at the same time through the socket, but we want to like we want the operation of sending data through the socket and receiving data back from the socket to be as isolated as possible. And the gen server is exactly what we can use to do that. So basically, we can ask the gen server. We can say that to the gen server, this is the command we want to send to Redis. Send it to the gen server and ask the gen server to just do the work for us and send the response back to us. So we would have something like I don't know, say send. Let's say our gen server process is called Radix, and as I said, gen server is a process, so the way you do requests to a gen server is just send messages, right? So actually, what we want to do, say we have there's actually a gen server.call function which basically just sends a message to the gen server and handles stuff like when the gen server is going to reply, or if the gen server crashes or timeouts and stuff like that. But what we do is, or here is, I mean, this is a PID, right? The PID, the process identifier of the gen server. And what we do, say we call, and by calling, I mean, say we send this request, which will be command, and this will have our command to send to the gen server. So what we're doing is asking the gen server, hey, can you perform this command for me on the Redis server? And this happens like in an Elixir process, which is not the gen server. Then in the gen server, we have basically we define callbacks in the gen server that the way airline knows what to call, but we have a callback in the gen server which is called handle call. So as you see, we called call here, and we're basically handling that call. So you can think of this like a request, right? So we're requesting stuff, and this callback just handles the request, like, right? So it's you call and you handle the call basically. And there's a bunch of stuff here. Right, this is you handle. So this is the actual request, right? So we're sending a tuple with commands, the atom command and the actual command here. Let's say this, so that the gen server can identify what kind of request we're sending. And here is where we handle, like we pattern match on the request we got, and this is the way we handle the request, the right request, right? We know how to handle the right request. So in this case, we will handle the command request, which is a request to send a command to the Redis server. And there's a bunch of stuff here, and there's the state as well of the gen server. So this is the way you let's just simplify this, call this S, but this is the state of the gen server, and this is where you actually have the socket stored, right? So since you can mutate the state of a gen server, of course, because nothing is mutable. No data structure is mutable in Elixir no longer. So basically, the way you modify the state in a gen server is you take the state as an argument in the handle, like handle callbacks. So you always get the state as an argument, and you return an updated state when you like finish processing the request. So this is the way. So yes, is that a hand raised? Nope. No, was just someone waving hi. So you basically just you can modify the state in the sense of like mutation on data, right? So the only thing you can do is take a state and return a new state. This is the basic of updating the state. So the state, let's say the state will be the socket in our case, right? The only state the server need is the socket. So this S will stand for socket for us instead of state. Let's say S is the socket. And here is handle call, the body of the handle callback will be executed sequentially and isolated in the gen server. So nothing else will happen in the gen server process except for the body of handle call, right? So there's no concurrency here. There's no parallel work. It just does that's what it has to do here, and before it can't do anything else until it's done performing the body of handle call, which is what we want, because we want the sending of messages through the socket to be as isolated as possible. So what we do here is actually what we did earlier, right? So we send stuff to the socket, and we say encode commands. So we will encode the commands according to the Redis protocol, which we don't care right now. But we send stuff to the sockets, and then here we can do the gentcp.receive. So we'll receive data over the socket. When you pass 0 to receive, it means receive all the available bytes that are sent from the server. And this will receive a TCP packet, which is just binary data. And then we decode the data because we don't know. This data is encoded through the Redis protocol. We want to decode it back to Elixir data structures. And basically, we decode data, and we have response. And then the way the Gen server framework handles replying to clients. So this is blocking until this. Okay, I forgot to tell this. This is pretty important. But when a process called genserver.call, the calling process will block until the Gen server replies to the process. And this is exactly what happens when you handle. So it will block until handled call is executed for that request and finish its execution, right? And it won't. So this is blocked until this call blocks until handled call replies for that call. A replies is just returning a value of a predefined value that it's in the Erlang documentation. So the Erlang expects you to return this value from a Gen server handler call function, and it's basically it's an example where the first element is reply, so it's just saying here's the reply. Then you have the actual reply, which is the one that will be returned to genserver.call. And then you have the updated state. So here we don't update the state. This is RESP in our case, right? Oops. So basically, what happens here is we're saying, going over the handle call again. We're just saying we send encoded comments through the socket. We receive the response from the server. We decode the response, and then we just this is the way we send it back to the client, basically. So this is what will be returned. genserver.call will return exactly what we return in the second element of this tuple. So in this case, it will return the response that the Gen server sends. Let's do this. Okay. That the Gen server sends. So this is a very, very I hope straightforward way to it's not easy because you have to wrap your head around this request response model inside your programming language and your programming framework, but it's it works well. And it's pretty once you get the hand of it, it's pretty straightforward. You have to think of it like a web server. So this could be a call to a web server, and this could be like the I don't know, the controller in that web server that says, okay, I'm handling. This could be the path in the web server if we're doing this analogy, right? So I'm handling this path. This will be like the mix of a router and the controller, but it says I'm handling this path. I'm doing this synchronously, so the client is still waiting until I do this. So until I process stuff in my controller, the client is still waiting. And then when I do this, it's like when I'm replying to the request. If I was a web server, I'd be replying to the request, and then that is when the client gets its response back, right? So the client only blocks until it gets a response back, and this happens this is the processing of the request, and this is sending the response back. So it's a little different on the mechanics of how you do request and response, but the main concept, I hope it's clear, because it's very, very similar to a Gen server, to a web server. It's a Gen server. So yes.
Yeah. So since all you want to do in this handle call is just update the socket.
Sorry, can you come closer to the
Yeah, since all you want to do is to update the socket state in this handle call, why not go ahead with just casting it via the Gen server instead of using a call? why do we want to use a call here? We want to reply.
Why do I want to use a call instead of a cast?
Yeah, we just want to update state on the socket. No, okay. Yeah, but is the reply really needed just when you just update the socket? So even if it is going to be an update on the socket, it should be a block. Correct, because if it is going to be a receive, then it would make sense that I need a reply from Reddit. Since it's going to be just an update, we might as well just ask it. Yeah, right, thanks.
No worries. So if I understood the question right, it was why use a call and not a cast, pretty much. And yeah, I think you guys responded to that. I hope. Like do me a thumbs up if you got the response. And oh, nice. Okay. All right. So this is works. Definitely works, and it's definitely better than what we had before, because now we're just opening a single socket in this Gen server, and we're doing this. We're sharing this socket between processes, and we're doing. We have this like request response model where clients just ask the Gen server to send. To talk to Redis for them, and the Gen server talks to Redis, gets a response back, and sends it back to the client. And this is how it is right now. This is not. This can work, and especially it can work especially if you do something like pooling processes. So what I mean by pooling is you could spawn several of these Gen servers. That I'm talking about here. So this is a single Gen server, right? So it's a single process. So all other processes that want to talk to Redis have to go through this Gen server, right? And this is what I mentioned earlier when I said that this can be a bottleneck, because again, this Gen server handles requests sequentially. And it basically serializes requests and handles them one at a time. So if I have many processes sending requests to the Gen server, it will not scale well. It will slow down the more processes I add that ask talk to the Gen server, right? So one easy way to make this scale well is we can have a pool of Gen servers. And by a pool, what I mean is I can spawn like several of these Gen servers, and then I can have a single process that manages the pool. So that would be a process that knows all the Gen servers that I have spawned, and other processes, external processes that want to talk to Redis will just talk to the pool manager, and this pool manager will say, okay, so this is a Gen server that is not doing any work. So here's the process ID of this Gen server. Talk to it. Talk to this Gen server. And then another process talks to the pool manager, says, hey, I want to send a message to Redis too. And this says, okay, I have these other 3 Gen server. So each Gen server will hold a different socket, right? But we're happy with that because the size of the pool is controlled by us. So the problem we had initially when each process would open its socket, then talk to Redis, and then close the socket would be that who knows how many processes will be in our system, right? So if our system is a web application, for example, built with Phoenix, we don't know how many processes will want to talk to Redis because each client request is a process, so it doesn't scale well in the sense that we have no control over how many processes will be spawned and by consequence how many sockets will be opened. So instead, having a pool, a fixed pool, so a pool with a fixed number of Gen servers this way we have control over how many sockets are open. So each gen server can still open its socket. So we'll have maybe 50 sockets open, so 50 gen servers, but we'll have control over, like if the web servers gets 1 billion requests in a second, then we'll still have just 50 sockets open, right? Which is, we won't crash Redis, we won't crash our server for too many like file descriptors open or this kind of stuff. So this is we can like make this much better using a pool, or there's like the and this is actually what I think Postgres, which is the Postgres client, and maybe MariaX, which is the MariaSQL/MySQL Elixir clients are doing. So they're basically handling, I'm not sure, 100% sure about this, but I think they're basically doing something like this. So they handle talking to the server, to the database, like one request at a time, but there's a pool of this gen servers that connect to the database, so that the actual work is actually parallel somewhere. But this is not what I'm doing in Radix, because I think there's a good alternative that makes this work, and it doesn't require a pool of servers, right? So the good, and this is what actually it's not an original idea. This is what Postgres did, at least a few months back when I wrote Radix. I basically just copied what Postgres was doing. So the idea is basically you handle the sending of the message through the TCP socket and the receiving of the response separately, right? So the idea is you send the message to the socket right away, and then you don't block waiting for the response like we're doing here, right? So in this code, we're just sending the request, then blocking these blocks, as you remember, receiving blocks until we get a response back. So that I hope you it's clear that when you do this, the whole gen server is blocking until it gets a response back from the server, because the gen servers can do just one thing at a time, right? So once a gen server is in an handle callback, is handling a request, it's just doing this, it's not doing anything else. So if we block here, waiting for a response, every other client that called genserver.call, because there can be multiple clients calling genserver.call at the same time, right? But as I said, the gen server is still going to handle this call just one at a time, right? It's going to serialize these calls and handle them one at a time. So the point is, if you block here, you're blocking the whole gen server, and you're blocking the whole set of clients that are waiting for a response from the gen server. So it's usually not something you want to do if your gen server is going to handle requests from multiple clients, right? So the idea is you still send stuff to Redis right away, but then you just return here. And so there's a way. So the reason you use this reply item when you're responding to when you're as the return value of an handle callback is because it's not the only possible value you can return, right? It's you can return multiple different type of values and basically tag in this value saying, okay, this type of return value is a reply. And as I said, when you're replying, you actually reply with a response to the client, and you update the state. But there's another response that you can, another return value for handle call that you can return, which is no reply. It's called no reply. And you only return the updated state with that because you're not replying to anyone. And what no reply means is the gen server, as soon as it returns, let's just throw it away. As soon as the gen server returns this from handle call, it will be able to handle other requests, right? Because I mean, it only blocks when it's inside an handle call, right? So as soon as it finishes this handle call and it returns no reply, it's gonna be able to handle new calls, right? To handle new requests. But the client still blocks because the client didn't get a response with reply and a response, right? So it's like it's the perfect situation, that the exact situation we want, where the client is still waiting for a response from the Gen server, but the Gen server is not for a response from the Redis server. So the Gen server can keep doing work. And the nice thing is that if two clients call this, like, let's say this happens in PID 1 and this happens in PID 2. So two different processes are making a request to the Gen server, and the Gen server will just handle the first request from PID 1, and it will say, okay, send the command through the socket, and then don't reply to PID 1. So PID 1 is still stuck on this call, it's still blocking on this call and waiting for the response. But the Gen server will be able to handle the request from PID 2 and send the commands from PID 2 to Redis as well. And so this is exactly what we want, because it's much, of course, we don't have to, it's much faster because we don't block on receiving data from the Redis server. So of course, the next question is, so like, how will we get data back from the Redis server, and how will we reply to the clients which are still waiting for us, for the Gen server to reply? And the answer is there is a function in the Gen server. So okay, so in handle calls you get, basically this is like the signature. This is the signature of an handle call. So you get the request, which is like in the web server analogy will be the path of the request, and then you get from, which is the requesting client, right? So it's the PID of this Gen server and a unique reference that identifies that call, but this is not important. But say this from value identifies the client, like identifies the request. Let's say this. So in the web server analogy, this would be the path to the request. This would be, I don't know, a combination of the IP of the client and I don't know, the session or whatever, or the I don't know. This will be an identifier of this exact request, and this is the state. So there's a function in the Gen server model, which is genserver.reply, which basically takes this from value and a response to reply to the client, and it responds to the request. So as I said, when you do genserver.call here, you're doing a request. This is handling the request, and this from value identifies the requests uniquely, right? So when you can do a genserver.reply and pass in that request identifier, and it will respond to this request. So this is where your client will actually stop waiting and get a response back. This may be a little like hard to wrap your head around, but I'm just gonna keep talking, and then you'll probably pick up, or at least you'll have like a broad understanding of what's going on. But so this is like, you separate the handling of the request from the actual replying to the request. So you can take these two steps apart, and you can handle them separately. And the nice thing is, I can handle this outside this handle call, right? So this is the time where we go back to, so let's freeze this for all this for a moment and get back to the Gen TCP stuff we talked about earlier, right? So when we talked about Gen TCP, we said that the way you get back the data back from the TCP socket is to say Gen TCP dot receive. But this is not, so this is the blocking way of getting data back from a TCP socket, or reading that data from a TCP socket. So we were doing this earlier, right? And as I said, this is the blocking way to receive data from a TCP socket. There's a non-blocking way as well, which is when you can ask the socket to be active. That's what you call this I think you this is when you connect. You do this when you connect. So you do connect. This will be localhost, other stuff, and then you say the option which is active true. So you pass an option to gentcp.connect. And what it means for a socket to be active, it means that you will get data from the socket as earlier messages to the process that started the TCP socket. So through to the it's called the controlling process of the socket, right? So in this case, I'm connecting to a socket from a process, and this process will be the controlling process of the socket. And when the socket is active, this process will receive messages, will receive the data from the socket as alarm messages. So basically, what I could do is connect, then I say gentcp.send, which is what we did earlier, and then instead of saying gentcp.receive, I would say I will actually receive an Elixir message. The format is TCP, and then the socket, and then the data. But this is exactly, and then handle the message here, right? So this is the way you can do this in a more asynchronous way, right? So you don't block on the. I mean, if you do exactly this, you will block because receiving messages, Elixir messages is blocking. But I mean, you can do this. You can separate the sending and the receiving becomes like asynchronous. Becomes it's done through Elixir messages. So you just handle Elixir messages as you would for any other type of message, and this is very, very nice for our Gen server, because if we do this pattern, it means that here we can just send, and then there's another callback in the Gen server behavior, in the Gen server like interface, which is a callback that handles Elixir messages, like whatever Elixir messages, even if they're not sent from a process that is actually performing a request on the Gen server. So it's called handle info, and it will take the message here and the state of the Gen server. And so if we since we okay, so I forgot to mention that we're of course connecting to the socket when the Gen server starts, right? So that there will be a callback in the Gen server that initializes basically the state of the Gen server, and that is where we were gonna open the socket. So all this to say that the Gen server is our controlling process of the socket, right? So the Gen server will receive all data from the socket as Elixir messages, and this handle info basically handles Elixir messages coming to the Gen server. So in this case, we can actually handle the messages showed below, which is TCP socket data. We don't care about the socket right now, but we basically handle exactly this message, and the data is the response from the server. And the nice thing is that this handled call, which handles the request, and this handle info happen like at separate times. They can happen concurrently, of course, because they're still happening both in the Gen server, and the Gen server can only do one thing at a time. It can do only sequential work, but they happen in separate moments of time. So let's just say look at what we're gonna do in the handle info call, which is now we have the data from the back from the server. So we're gonna just decode the data because it's encoded in the Redis protocol, and we're gonna probably just what we wanna do is wanna Gen server.reply this data to the client that asks for this command, right? This is a Redis data here is a Redis response to a Redis command that someone sends. So the Gen server sends this command through the socket, but the client asked the Gen server to do this. So this is how we want to reply to the client that asked that they wanted to perform the command, right? So this is the from I talked about earlier. But so it's straightforward, and then we would reply here again, no reply state, because we don't we don't know who to reply to. This is just an Elixir message sent to us by whoever, just not a client that's asking us to do something. It's just a message sent from someone. In this case, the TCP socket. So we don't want to reply here. But the thing is now is where it's from. Like how do we know who to reply to? How do we know which client asked us to send a Redis command and like the response of which is this? So how do we know who to send this response back to? And so this is what we're gonna of course find out in a moment. But I want just to reiterate what we're doing. Say that I want to focus the moment on the how this handle call and handle info stuff happens in separate moments, which is like the key to speeding this up in respect of what we had before. So say like two clients like this, the same situation as before, where you have two clients asking the gen server to send different commands to Redis, right? As I said, the gen server is going to handle. So this is I mentioned this at the beginning, but the way the gen server performs the request response cycle is every request is a message, an Elixir message that is sent to the gen server, and every response is an Elixir message that the gen server sends to the requesting process. So call here is actually just a wrapper around sending a message and then receiving the response, right? So so when we do the first call, the gen server is going to handle the first call and send the TCP data to the Redis server. But this is going to happen like right away, right? Because these are one after the other. So this other request is going to happen right away, and it's going to probably happen before the Redis server can reply, right? Because this is language speed that like Redis is still TCP speed, so it will be slower probably. So the gen server will handle the call from P2. The Redis server has replied with the response to the request from P1, right? So the gen server will happily handle the P2 call and send the data, the encoded commands that P2 wants to send to Redis. It will send them to Redis right away. So the situation now is the gen server sent two requests to Redis, basically two sets of commands to Redis, and the comments from P1 and the comments from P2, but it still hasn't got anything back from the Redis server, right? So this already means that we did speed things up some way, because if we like the way we did things earlier, which was send then receive right away, was to what would have happened is P1 sends the command, and then the gen server blocks until it receives the command from P2, from P1, from like the response from Redis, sorry, for P1, and this is blocked, and P2 can't send anything to the gen server. I mean, it can send to the gen server, but the gen server won't handle P2's request until it finished handling the request from P1. So this way. The way we're doing things now is that we're parallelizing this work, because now we're actually handling the requests from P1 and P2 kind of in parallel, right? So because we send the data for the commands for P1 and P2, even if we didn't get any response back yet. So we started handling both requests, right? And at some point we're sure that if we're processing the request from P1 first and the request from P2 second in this, like if we're processing with them with handle call in this order, we're sure that the responses from Redis are going to arrive in the same order, because we send the command first. So Redis, we're sure that Redis got that command first, and we're getting a response back from Redis for the first command first, of course, and then for the second command. So what we can do here too, so the problem, as you remember, is that we don't know who to reply to when you get the response back from Redis. And so the solution, at least the solution I applied in Redis, is you basically have a queue. So as I said, this Gen server has a state, right? So we can keep in this state, we can keep a queue of clients that ask the Gen server to send commands to Redis. So when we in handle call, instead of just sending the commands to Redis and then returning right away, what we do is first we enqueue the from client in the internal queue. Let's say this is so we update the state by saying so say the enqueue just takes the state and then updates the queue of the state and returns a new state, right? So we have a queue we introduce a queue in the state, and we can enqueue clients in this queue. And so basically, whenever we're handling a request from a client, we just enqueue the request in the internal queue and then send the messages from TCP. And then this becomes trivial because when we get a message from the TCP server, from the Redis server, the client we have to reply to, it's just gonna be the next one in the queue, right? Because what happens is, so whenever a client makes a request to the Gen server, we put it in a queue, put the client in a queue, and send the request to Redis. When we get back the response from Redis, the next client in the queue will be the one that response is directed to. So I hope this is not very easy to explain in short time, and it's hard to wrap your head around it very good. But you can I wrote a blog post on this, so I'll link about this. A link to that later. But I hope you're understanding the whole philosophy of doing this, because now that we do this, we know we're responding to the right clients, but this is now it's much so this becomes asynchronous, right? So these calls, so the calls of the clients to the Gen server still appear synchronous, which is what we want, because we want the client to block until it has a response from the server. So we still want this to be synchronous. So when we do a call, the client still blocks, but the Gen server is able to handle other calls from other clients that want to send comments from Redis to Redis while our first client is waiting. And then it's gonna just, whenever the response, as soon as the response from the client, from the Redis server comes back to the Gen server, it's gonna respond to all the to the corresponding waiting clients, which is the next one in the queue, right? The queue is first in, last out. So it's a queue. You just you put new clients to the back of the queue and response to clients in the front of the queue. So it's like the queue is a window in this sense. And this is so I think I have so much more stuff to say, but I think this is like the important stuff that I want to know, which is how you do. This is like how you try to parallelize as much as you can in Elixir, right? There's actually I'm just gonna mention this because it's fun, but I actually did optimization over this, which is, what if instead so this what happens is that many clients ask the Gen server to send commands to Redis. The Gen server is going to have a hard time processing the responses from the Redis server, because it's going to be handling the sending of the requests to the Redis server. So as I said, these two functions, of course, can't execute in parallel, because they're still executing in the Gen server, and so they're still executing one at a time, either one or the other. So if we send many requests to the Gen server, what's going to happen is it's going to spend much like a long time handling all these requests and sending data to the Redis server, and it's going to like have a hard time having the chance to process this the messages they get back from the Redis server. So the idea is, what if we do the sending in an Elixir process and the receiving in another Elixir process. So we basically we can parallelize this even more by having a process like a John server that only takes care of sending the messages to Redis and not receiving the messages back from Redis. And then this John server spawns an internal, very strictly related other John server, which just receives stuff from the Redis server and responds back to clients. So this way, the first John server only takes care of sending stuff to Redis, and the second John server only takes care of receiving stuff from Redis. And these two happen like in separate processes. So we don't like encounter we don't go into the situation where if many clients request something, then we have to we have a hard time processing the responses, and we don't go in like stumble in the situation where Redis is sending us many responses, and so we're handling the responses here, and we can't handle the new requests in the handle call callback, right? So this is even I just mentioned it because so that you heard of it at least some way. But I'm gonna for sure write a blog post on this last part that I talked about now. But everything else I talked about, it's much it's described like in much detail in a blog post I wrote. I'm gonna tweet it out to Akash probably so that he can forward it. But it's exactly basically I basically just read the blog post right now, so it's everything is very much more clear there. And yeah, so I think that's it for now. I as I said, I could talk really for days about this, but I won't. So do you have any questions? Okay. So I think we're good.
Okay. Go ahead.
Thank you, Andrea. Thanks a lot.
No worries.
I hope you enjoyed giving this talk.
Yes, definitely.
Okay.
Okay.
Yeah,
Have fun. Bye,
Bye-bye.
everyone.